Next definition. So curl of a, suppose f vector is a differentiable vector point function defined at each point x, y, z in some region of space. Then the curl of this function is defined by curl of it is denoted by this curl f, which is equal to del cross f, or sometimes called the rotation of f vector. Yes, the curl of f vector or rotation of f vector, right? Suppose f vector is f1i plus f2j plus f3k. Always del cross f is a vector multiplication, right? So cross product. So del cross f equal determinant so I, j, k. Then the del is nothing but dou by dou x or dou by dou y, dou by dou z, and then f1, f2, f3. To expand this determinant, you may get the value of del cross f. So which is called what? The curl of or rotation of f. Suppose this del cross f is equal to 0. Then the f vector is called what? So irrotational vector. Irrotational. So the value of del cross f is 0. Then the f vector is called what? Irrotational vector. In the problem, if f vector equal x squared minus y squared plus 2xz into I plus xz minus xy plus yz into j plus z squared plus x squared into k. So find del dot f, del cross f, del dot del cross f at the point 1, 1, 1. But del dot f na enna? Pona class la paatha definition illaya. Div f அல்லது del dot f ரெண்டு ஒண்ணுதான். So del dot f நாலும் ஒண்ணுதான், div f நாலும் ஒண்ணுதான். But del dot definition என்ன? I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot f vector. இந்த கொடுத்திருக்கிற vector x square minus y square plus 2xz into I plus xz minus xy plus yz into j plus z square plus x square into k. So dot product. So dot product and so corresponding element multiply பண்ணனும் இல்லையா? Dou by dou x of this என்ன வரும்? 2x என்ன எழுதிக்க. So dou by dou x of x square minus y square plus 2xz and plus dou by dou y of the second term xz minus xy plus yz and then plus dou by dou z of z square plus x square. So dou by dou x ne differentiate partially with respect to x. So you may get what? 2x plus 2z plus differentiate partially with respect to y. Will now 0 minus x plus z and plus dou by dou z of this. So 2z, right? So at the point 1, 1, 1. So at 1, 1, 1. So 2 plus 2. Replace x, y, z by 1, 1, 1. So 2 plus 2 minus 1 plus 1 plus 2. This will get cancelled. 6. Right? So this is a divergence of f or del dot f. Right? The second question, del cross f. Del cross f na enna? Curl of. So del cross f is nothing but what? Curl of is equal to del cross f. What will be the definition? The determinant I, j, k. The definition of del is dou by dou x, dou by dou y, dou by dou z. So So vector product. So vector product பண்ணும்போது determinant ijk இல்லையா, the vector quantity. So dou by dou, that is a component of I, coefficient. What is that? X square minus y square plus 2xz. So coefficient of j, xz minus xy plus yz. Then here z square plus x square. Expand it. So I vector into, so move this column and this row, multiply these two, that means operating on respect to y. So dou by dou I of this, so 0. Then dou by dou z of this, minus x and minus y and minus j into, so omit this column and this row. So dou by dou x of this, so 2x minus dou by dou z of this minus 2x, right? Then plus k vector into, so omit this column and this row. So differentiate with respect to x, so z minus y and minus differentiate with respect to y, so plus 2y, right? And at the point 1 1 1, this is equal to x is 1, y is 1, so minus 2i, then this is 0, then plus, you know, 1 minus 1 get cancelled, so 2, so plus 2k. So which is curl of R del cross F, right? Okay. Now del dot del cross F. Third question enna, del dot del cross F. So del vandanade I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot. So del cross F. So del cross F க்கு வந்து இதே தான் எடுத்துக்கணும், நீ என்ன வேரியபிள் இருக்கோ அதை எடுத்துக்கலாம். அதுக்கப்புறம் தான் என்ன பண்ணணும், பாயிண்ட் சப்ஸ்டிட் பண்ணணும். இப்போ இது என்ன இருக்கும், மைனஸ் எக்ஸ் மைனஸ் ஒய் இன்ட்டு ஐ வெக்டார், இது 0, ஸோ ப்ளஸ் 0 ஜே வெக்டார், then here plus z plus y or y plus z into k vector, right? Now dou by dou x of this, so dou by dou x of minus x minus y plus dou by dou y of 0 plus dou by dou z of y plus z. Then now minus 1, this is 0, this is plus 1, so this is equal to 0, right? Okay. The next problem, show that f vector equal to y squared minus z squared plus 3yz minus 2x into I plus 3xz plus 2xy into j plus 3xy minus 2xz plus 2z into k is both solenoidal and rotational. So solenoidal, அப்படினா என்ன prove பண்ணனும்? What is the definition? If del dot f equal to 0, then we say that the f vector is solenoidal. So to prove or to show del dot f equal to 0, right? So what is del dot f? So del dot f equal to, so what is del? So I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot f vector. So this is f vector, right? Or you can write that y square minus z square plus 3yz minus 2x into I vector and plus 3xz plus 2xy into j vector and plus 3xy minus 2xz plus 2z into k vector. So dou by dou x of this, So differentiate partially with respect to x, or you can write like that. So dou by dou x of y square minus z square plus 3yz minus 2x plus dou by dou y of the second term. So 3xz plus 2xy, then plus dou by dou z of this 3xy minus 2xz plus 2z. So differentiate with respect to x, so minus 2, and plus you differentiate with respect to y, so plus 2x, then plus you differentiate with respect to z, this is 0, then minus 2x plus 2. So this is equal to 0. So therefore F vector is solenoidal. Next kind of proof no irrotation. Irrotation to show that del cross F equal to 0. If dot product is 0, the effect is solenoid. If the cross product is 0, then the vector is irrotation. So to prove del cross F equal to 0, so del cross F equal to determinant, so I, j, k, so dou by dou x, dou by dou y, dou by dou z, and then y squared minus z squared plus 3yz minus 2x, here 3xz plus 2xy, and here 3xy minus 2xz plus 2z. So I expand it, so I vector into, so make this column and this row, so differentiate partially with respect to y, so 3x with respect to z, so minus 3x and minus j vector into, so make this column and this row, so differentiate partially with respect to x, so 3y minus 2z, then differentiate with respect to z here, so minus plus 2z, then minus 3y plus k vector into, so omit this column and this row, differentiate with respect to x, so 3z plus 2y, differentiate with respect to y, minus 2y minus 3z. So I think it's get cancelled, right? So this is 0. So 0i plus 0j plus 0k. So this is equal to 0 vector. So therefore the given F vector is irrotation. Clear? Next problem, show that the F vector equal to y squared plus 2xz squared into I vector plus 2xy minus z into j vector plus 2x squared z minus y plus 2z into k vector is irrotational and hence find its scalar potential. So this type of problems are very important. So first you have to prove that the given vector is irrotational. So that is you have to prove what? Del cross F equal to 0. So first you prove del cross F equal to 0, right? So by definition, so del cross F equal, so determinant, so I, j, k, then dou by dou x, dou by dou y, dou by dou z, then y squared plus 2xz squared, then 2xy minus z, then 2x squared z minus y plus 2z. So expand it, so I vector into, so omit this column and this row, so differentiate with respect to y, so minus 1, then differentiate with respect to z here, so plus 1, and minus j into, so omit this column and this row, differentiate with respect to x, so 4x and minus differentiate with respect to z, so minus 4x, right? So differentiate with respect to x here, 4x z, right? With respect to z பண்ணும்போது again 4x z, then plus k vector into, so make this column and this row. We differentiate with respect to x, so 2y minus, differentiate with respect to y, minus 2y, right? So this get cancelled, so 0i, then this is also 0, so minus 0j, then plus 0k, so this is equal to 0 vector. So therefore, so given vector is irrotational. So whenever the vector is irrotational, suppose let phi be the scalar potential, so let phi be a scalar potential of f. If f vector is irrotational, so there is a result del phi equal to f vector. Del phi equal to f phi. What is del phi? There is a gradient of phi. What will be the definition of del phi? Psi into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z. This is equal to given f vector y squared plus 2x z squared into I vector plus 2xy minus z j vector plus 2x squared z minus y plus 2z into k vector. The left hand side is a vector, the right hand side is also a vector. When the two vectors are equal, the corresponding components are equal, right? So therefore, which implies what? So dou phi by dou x equal to y squared plus 2x z squared, then dou phi by dou y equal to 2xy minus z, then dou phi by dou z equal to 2x squared z minus y plus 2z, right? So integrate with respect to x. So keeping y and z as a constant, so you may get 1. So phi equal to xy squared plus 2x squared by 2, so x squared z squared plus a constant function of yz. So here integrate with respect to y. So keeping x and z as constant, so phi equal to with respect to y, so x y squared and minus yz plus a constant, so f2 of xz, right? Then here integrate with respect to z, so keeping x and y as constant, so phi equal to, there we go, x squared z squared minus yz plus z squared plus f3 of xy. So from 1, 2, 3, so phi equal to, how we can write phi? You write all the terms in the equations 1, 2, 3. If any term repeated, write only one time. Alright. First write these two expressions, x y squared plus x squared z squared. Now second equation, already x y squared is there, so this is a minus yz. Then from this x squared z squared, you returned it, so minus yz plus z squared. Then instead of f1 of yz, then f2 of xz and f3 of xy, you simply put a constant c. So which is nothing but what? The scalar potential of the given vector. So given r vector equal to is the position vector of the point x, y, z, right? So r vector equal to what? So xi plus yj plus zk. Then modulus of r vector, root of x squared plus y squared plus z squared, which is equal to r, right? So r equal to, so r squared is squaring on both sides, x squared plus y squared plus z squared, right? So differentiate partially with respect to x, you may get 1. So 2r dou r by dou x equal to x. So dou r by dou x equal to x by r. Similarly with respect to y, dou r by dou y equal to y by r. Then dou r by dou z equal to z by r, right? Okay, remember these results. Then del squared r power n. So del squared r power n is nothing but what? So del dot del r power n. So we need del r power n, right? So del r power n equal to 1? I into dou by dou x of r power n, plus j into dou by dou y of r power n, plus k into dou by dou z of r power n. So differentiate with respect to x. So I into n into r power n minus 1 into dou r by dou x, plus j into n into r power n minus 1 dou r by dou y, then plus k vector into n into r power n minus 1 dou r by dou z. So dou r by dou x is x by r. இப்போ n into r power n minus 1 காமனாக வெளியே எடுத்துடலாம் இல்லையா? So n into r power n minus 1 into, so dou r by dou x என்னது x by r. So x by r into I vector plus இதோட ஆன்சர் y by r into j vector, இதோடது z by r into k vector. So you can take 1 by r outside. இப்போ n into r power n minus 2 ஆயிருமா, by r போட்டினா இது என்ன இருக்கும், xi plus yj plus zk, which is equal to, this is r vector, right? So n into r power n minus 2 into r vector. Okay, remember this result. You substitute in 1. So del squared r power n equal to del dot del r power n. So del dot del r power n is nothing but n into r power n minus 2 into r vector, right? Now that is the result. So del dot phi u equal to phi into del phi dot u vector plus del phi dot u vector. So there is a result like this. So here this is phi and this is u. You apply this result. So phi, so n into r power n minus 2 into del dot r vector, right, plus del phi. So yeah, so take it n outside. So del into r power n minus 2 dot r vector, right? So del dot r, our answer is 3 இல்லையா, del dot r per. So del dot r equal I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot r vector, the xi plus yj plus zk. So dou by dou x of x is 1 plus dou by dou y of y is 1, dou by dou z of z is 1, so 3. So this is what? So del r power n equal to n into r power n minus 2 into r vector, right? For del dot r on the 3 minutes plus n into, so n is a constant, so that's why I take it outside. So del r power n minus 2 or del r power n minus 2. So you replace n by n minus 2. So n minus 2 into r power n minus 4 r vector, right? So n minus 2 r power n minus 4 r vector dot r vector. So r vector dot r vector r square. So 3n r power n minus 2 plus n into n minus 2 r power n minus 4 r square. Then combine minus r power n minus 2. So 3n r power n minus 2 plus n into n minus 2 r power n minus 2. So you can take r power n minus 2 outside. So n. So n into r power n minus 2, take it outside. So 3 plus n minus 2. When I go n plus 1, yeah. So n into n plus 1 into r power n minus 2. So this is 1. So del square r power n, right? What are to deduce? If del squared 1 by r, that is 1 by r satisfies Laplace equation. So to prove 1 by r satisfies Laplace equation. So that is to prove, so del squared 1 by r equal to 0. So put n equal to minus 1 in this result, both left hand side and right hand side. So you may get what? So put n equal to minus 1. So del squared r power minus 1 equal to, so minus 1 into minus 1 plus 1 r power minus 3. So this is 0. So r power minus 1 is nothing but what? 1 by r. So del squared 1 by r equal 0. So therefore 1 by r satisfies Laplace equation. Okay, try this problem. So show that the f vector equal, this is solenoidal. The next problem, the f vector is sin y plus z divector like this, so is rotational. So in this problem you have to prove del dot f equal to 0. So here del cross f equal to 0. Then here f vector is not irrotational. So that is you have to prove del cross f is not equal to 0. And then you multiply this f vector by x squared y z cube, you may get irrotational, right? You multiply each term by x squared y z cube, you may get irrotational. And then you find out corresponding scalar potential, right?